Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and today we're going to look at some upgrades to the mini DualPole motor here. And so what we're looking at today is we're going to be replacing the former coils, which are right here, with these coils here. And the improvement is same inductance, but this is 19 gauge wire and this is 18, and this is a 1/2 inch by 1/2 inch core. So it functions just the same. It's going to give a little bit of improvement, and these ones are the ones that are available, so that's why we had to do it. We may go with some other coils in the near future, but for now that's the upgrade. So we're going to run this. So starting off, what we're going to do is just run it with double spacing. So this is a single spacer between the bearing and the rotor. This inner side goes against the bearing. Now this is going to be basic instruction video here for assembling. The kits that are unassembled are mostly assembled, and there's just a few things to notice. So that's one of them. So the bearing is placed on the outsides of the plates, so the bottom and the top, and we epoxy them in there so that they don't wiggle around. And then in this case we're going to put the spacer on the top one. We're going to face it this way, and the bottom one we're going to face it this way. That way the larger area goes against the rotor and the smaller area goes against the bearing. So we're going to run this double spaced now because there's a lot of lot more core material, and it's going to be running about 2 amps only at 12 volts. Well, it's going to give us some pretty good results. So let's look at that, and then we'll change it over to a single space. So we'll start off by turning on our meters. And these are just cheap meters, although they're true RMS. Just so people can see how to run this basically. Alright, so this is the input battery here. This is the charging battery. And this is just to run the Arduino, I should say. And the gate driver and the gate of the MOSFET. So what we're going to do is change this around this hall to the ideal setting for startup and RPM. We're not loading this down, so this hall sensor, which has the south pole facing down, and the south pole of the magnets are facing up right here. So let's start it off. Whoops. I have moved the over. So we're doing 12 volts. This does either 12 or 24 volts at the moment. And what we'll do, so you can see the amperage started off really high and went down. So the charging battery was charging faster initially because there's a lot more amperage. So the input to the output on the two battery banks here are about equal. And then of course we have this generator coils, which are these center coils, 4 coils here. These are going to this LED, 100 watt LED bulb, and this will change You can see if I turn this hull to about top dead center, we're going to get a lot more brightness. Of course, we're going to draw more energy. So we can get this up to speed. Now this goes, I believe I had it at about 8,000 RPMs. When I shorted it out, so we'll get this thing up to speed here. So what I'm doing is I'm shorting out the generator coils. All the generator coils are in series with each other. So inside I have them connected in series, and then this wire over here going to the output of the variac, which is, I just have it backwards, is going through the variac right now, and this is the input of the variac. I'm just shorting out so we can get up to speed here, just so you can see. This is very well balanced now, and you can see it's charging and everything is going well. So now what we'll do is we'll do this. Anyway, that's where we're going to have it right now. So we can change power level. The generator coils right now are not loaded down very much. The motor's not really loaded down very much by the generator coils because there's a bigger gap, because I have two spaces here. Between, I can't really see the camera while I'm doing this one. So you can see the double spaces there. Oops. Back up here. So at a certain point, what I was getting at was the generator coils are a relatively low voltage output right now because of the spacing. When we go to the single spacing, we will have more output. They'll draw more power and so forth. Anyway, this bulb is running fairly smooth if we have the right capacitance across this. Now this is on the output. We can add more capacitance on the AC side with an AC cap, if I had one around here. So let's stop it now and talk about we'll let the voltages settle here. The input one will come back down because it's under a voltage drop, and then we have a voltage rise under the charging battery, but definitely this is slightly discharged and this is slightly charged. Now what we're going to one of the options we have here is to have on the charging output, if we place, this is the positive terminal of a capacitor here. This is a capacitor pulsar, as I call it. So if we were to place this here and run the input or sorry, the output from the charging to this leg right here, and then on this part going to the battery, the center anode of the SCR, going to the negative terminal. Then we have something that transduces the energy from a negative energy to a positive. So right now we're charging it pretty significantly with the negative energy because of the high, you can determine that by the high spike, the fast rate of change in the MOSFET with the gate driver creates a very negative output. So the faster the rate of change, the more negative you're going to have. And the negative doesn't really allow you, depending on how much negative you have and how much positive really energy you have, will determine whether you can rotate the batteries around. Over time, if a battery becomes more and more negatively charged, you can't run the motor with that. And that's, of course, a big debate. And you can try it for yourself and see. But with what I'm trying to say is, when we create the positive current, which is what we're doing in this capacitor, then we can more positively charge the battery. So every time you pulse something, you still have a negative element taking place, and that's where your gain is. But if you don't have very much positive current going through the system, then your battery will become negatively charged. So in this case, you still have some negative pulsing from the SCR, which gives you a gain, a significant gain, but you have the current from the capacitor charging up the battery as well. So let's take off camera here and get a close up, and what we'll do is look at the circuit a little bit more. So first of all, we're looking at, you can see this is just before top dead center. So we're talking about turning this. So you can see that it's relatively easy to spin this because we have a pretty big gap there. So if the magnet is resting right here, and there's 8 magnets all around, you can see where I have positioned the Hall. So when I moved it right about top dead center, then I was getting more power out of the generator coils to light this 100 watt LED. Alright, so you can see the circuit. So what we have here, this is just for the hookup to explain, because the circuit board, even on the unassembled one, comes assembled, and all you have to do is add the black wires from the coils. The top wires, well, in this case, they're both at the bottom, but you have to determine which wire on the coil is going to be your input from the input positive terminal, and that's connected also with the charging negative terminal. So that is all connected right here. And I also have a capacitor across the coils. Actually, I have that, yeah, across the, actually, so we have the positive terminal of the capacitor connected here, the positive of the input battery, and the negative of the charging battery. And then we have, sorry, the negative terminal here is connected underneath to the negative bus. Negative bus terminal is also connected to the Arduino negative and also to the negative terminal of the input battery. So there's that black wire is going right here under the board and it's connecting up to the source terminal of MOSFET. So this is the MOSFET, this is the diode, even though it looks like a MOSFET or transistor, it's in that package. And this center terminal here is the drain of the MOSFET. This is going to the 4 black wires here, to the negative side of the coil. And again, the 4 motor coils positive terminals, the red wires, are going to the red wire of the input battery and the charging negative wire. So that's really all it is, and all you have to do is mount this hull. It's going to be already bent for you, and you can position this support wire as you desire so it doesn't vibrate around, and clamp it down. And then what I usually do is give myself make this kind of flat here so that when I spin it I don't drag my hand across that, cut my hand or something. So this one was a little bit higher up with the ends of the rods than I usually do it. So then what I do is I glue these in with hot melt glue. That way you can always remove them if you want to. Okay, there's the batteries, you can see where they're at. So, you know, the washers and all that are pretty evident here. You have a lock washer and a regular washer, and these are all the feet, so forth. Now there is a potentiometer here which determines your power, your speed, and that's turning clockwise. Fullest clockwise position is maximum. So when you're going to run this at 24 volts, you want to turn that down to start with and then turn it up accordingly. Now where it's going to be critical is as we put this single spacing next, you will notice that this on time may need to be adjusted a little bit lower, especially at 24 volts. We're only running 12 volts input right now, but 36, 48 we have to actually change the programming so that that comes on a lot less on time. So we'll go now to the next single spacing and see what happens. Alright, it comes with an Allen key, and these rotors are already assembled. You may want to put epoxy on the surface of them. I have pressed them in, and the epoxy may prevent any from popping out that may be a little bit loose. Once in a while I've had that. And that way also, if something ever gets in here, it doesn't scratch there, but it will put a little bit of resistance. Crazy glue doesn't really work. Use epoxy. Anyway, you have this Allen key that what you want to do is turn it with your hand and then use something to tighten it further. So we've removed these And now I'm going to, so you can see what I've done is I've put a, I've filed a flat. Now I don't do this for you unless it's assembled. If you don't do this, good luck trying to pull the rotor off from the shaft, because it is going to create a burr. So it may be a little difficult for me to get this back through there. It's very, very well machined, very tight. So again, this is what I was talking about. You want to put it this direction so that that goes against the bearings. The south magnet indicates the bottom one going facing upwards. So now this is going to be a lot tighter. Don't forget to put the spacer in. Now, when I used the flat, I made it larger so that we can move it around and have the ability to have one or two spacings. So I'm going to put this together in the same position. It's going to just want to go where it needs to go, but you want to make sure the holes are lined up. And then you just want to tighten it snug. So now it's significantly harder to turn. Now this one already has the lube that I sell, the Bishop's oil, and that makes a significant difference. And you don't have to worry about it ever wearing out your bearings. So what we want to do now is turn these back on. These should have settled more. So you can see, oh, disconnected this, that's why. Make sure everything else is connected. All right, so we have 1285 and 1226 on the charging side. So now we're going to hook up Arduino. And let's give it a go. So what I'll do in the next video, the next portion of this video is we'll make this double stacked. I'll replace these rods here and I'll double stack it. And then what we'll do is we're not going to do the double spacing in that case. We'll do the single spacing. So now what I'm going to do is move this. You can see 4 amps. Get some decent charging. And then we can adjust power level. So where you place the hull is pretty critical. So this is pretty much at top dead center right now. So we could load down the load this down more by putting more capacitance across the input side of the variac or the output side of the there. So I've shown that in other videos, so I don't really need to show it right now. Alright, let's go on to the next section. Alright, we're back here and we've added the double stack. I use the same board, but we've added a MOSFET and another diode here. Actually behind here. Here is the diode. It's a double diode. And then you've got MOSFET here that I've added. Oops, right here. So actually I reversed the wires here so the colors are backwards. So this is supposed to be the black wire and this is supposed to be the red wire coming down. It doesn't really matter the direction of the coils. Anyway, we're going to run this. You can see the voltages are changing back because I just was running it for a little bit just to make sure everything was fine. And now we're going to run the variac a lot less because we've got double the coils here. So let's get started. Uh-oh. There we go. You want to hear that click? So I thought it was actually going to be a lot harder to start it, but it's not really that hard. It's worked out pretty good. So now we're going to start the variac. I'm going to turn it up so you can see we're starting to load down. After we go beyond a certain percentage, like, so we speed up when we short it out. As I showed before, we still got pretty good charging. We're at 5 amps here, but now we're going to load down. We're approaching full brightness with the LED. You can feel the heat coming off of it because we're at 6 amps now. So we're producing pretty much the power that it's taking from the input battery. But we're charging the charging battery, as you can see the voltage here. at the rate that this is discharging, approximately, or ideally. And then we're also producing the same amount of energy from the generator coils here. Now I can draw more, or we can try and I can't even hold that because I have to use something. Try and hold that down. But this is a fairly high RPM, and this can produce significant torque at lower RPM. So that will function just like a regular motor here, or we can have these as generator coil output. So if we were to use the torque, we would short out that generator coils to give maximum torque, and we would lower the input. So I'll bring the camera around. So you can see what we've done here. Like I said, the wires are reverse colored. And there you can see the added components here. So we just doubled this. And then we shared the output. And that's that. So let's turn it off. And we can look at it. Let's make sure we disconnect from everything here. So we can see we went back to the single spacing there on all the layers. And then you can see the Hall position. Now, as I said, we can move this more towards top dead center. The faster it goes, the more you're going to bring it to top dead center. And then at the higher voltages, we would have to move. If this is clockwise rotation, because you can run it the opposite way if you want to. You just have to move the Hall. And then what you can do with 24 volts, you'd be over here more. 36 volts, you know, right there, 48 volts there, but we'd have to send you a different code for the 36, 48 volt, or you'd have to turn the potentiometer down further and not ever turn it up to full. So that is that. Thanks for watching.